Hello everyone, myself Meraban. I'm currently in my second year of studying computer science and engineering at Srinivasa Ramanujan Institute of Technology. Now, I'll be explaining COCOMO model, which is an estimation technique, and it is a topic in a course software engineering. Let us see what all the contents does my PPT slide consist of. Starting from introduction, software project types, types of COCOMO model, advantages, disadvantages, conclusion, and finally reference. Reference which means from where I have collected all the content. Starting with the introduction. Basically, this is an estimation technique which was developed by Barry Boehm in 1981. This concept, COCOMO, comes from constructive cost model, which means we can see here I have highlighted that COCOMO, which directly refers to first CO is constructive, second CO is for cost, and MO is model, constructive cost model. Here, COCOMO is the one which gives meaning constructive cost model. That's it. And it is used to estimate cost, effort, and development time of a software project basis on some factors like lines of code. Here, estimating is an important aspect in software development, software project. Here, the number of lines of codes are taken as input for estimating all these factors. Without any estimation, it doesn't make a sense to start making a software project. So this is why Barry Boehm is one of the scientists who developed this COCOMO model for estimating different factors related to software project. He characterized projects in three different categories. Like I have mentioned in this diagram, there are three, and those are organic, semi-detached, and embedded. Organic is nothing but a simple one in which the team size is small, and also it consists of well-defined requirements. Like in waterfall model, we can see that the requirements are all well defined without any constant changes in the requirements. So in the same way, organic totally refers to a simple project with small size. And the next one comes semi-detached, which is some intermediate projects with moderate complexity. Here, the size of team also somewhat increases when compared to organic one, and embedded lies of that to semi-detached, which means the size is somewhat larger when compared to these both organic and semi-detached. This is complex projects with tight constraints and high integrations. So these are the three different types of software projects which was characterized by the scientist Barry Boehm. And let us see the types of COCOMO model. COCOMO model basically consists of three different types. Those are basic, intermediate, and detailed one. We'll be seeing some formulae related to these particular models and how we'll be going to calculate the effort, time, and all the factors related to the software projects. Let us see those formulae and also some detailed content regarding these models. Let us start one by one. Starting with the basic COCOMO model. As just like the name suggests, basic COCOMO model, which means it's totally basic and it doesn't give something curate or something exact values. This only gives quick and slightly rough calculations of software costs. It estimates effort in person months. The effort which was being calculated using some formulas are being represented by using the units like person months. This is the units for effort. And for time, we are having units like months. And for calculating this time also, we'll be having some formulas. We can see here, I have mentioned the formulas of those effort and time. Effort, which is E equals to A into kilo lines of code. I've mentioned, right, this more specific model takes Here, lines of code as input for calculating, for estimating a software project. So that is kilo lines of code to the power of B. And time is equals to C into effort, which was calculated by using this particular formula to the power of D. Here, percents required is calculated by dividing effort by effort with time. So what are these A, B, C, D? These are nothing but the constants, and we are having the values of these four constants on the basis of organic, semi-detached, and also embedded ones. Let us go through those values mentioned in the table. For A, B, C, D, we have all the values like for organic, semi-detached, and also embedded one. These are the values, and these are used for calculating, for estimating a software project. And here is an example of how a project can be calculated on the basis of kilo lines of code. Here, estimated project size is given as 100 kilo lines of code. And for organic one, we'll be considering this first particular column, row, which is organic one A, B, C, D. Here I have given formula in the previous slide like effort is equals to A into kilo lines of code power B. Here the A value is 2 power 4 into kilo lines of code are 100. Here kilo, which refers to the 1000 lines of code, which means 100 kilo lines of code is the input for this calculation. And after calculating this, we'll be getting 261.53%. This is the units for effort. And for time, 2.5, which is the direct value of constant C into effort whole to the power of D. After simplifying this, we'll be getting 22.89 months. In the similar way, semi-detached mode and embedded mode is also calculated by using the same formula, but here the values of those A, B, C, D constants are going to be changed. For the semi-detached one, we'll be using the second row values, and for embedded one, the last row values are being used for calculating the effort and the time. And we can see here the time taken, the time estimated for the organic, semi-detached, and embedded one is going to be increased. For organic one, we just require 22.89 months, and for semi-detached, which is the intermediate one of these both organic and embedded, is 23.72, and for embedded one, it obviously requires 24.98 months. So this is all how we calculate effort and time in basic model. And also please remember that this basic model only gives some rough calculations. To overcome this, we have an intermediate COCOMO model. Here, those values are being accurate estimations. Basic COCOMO model relies only on lines of code, which means basic COCOMO model only takes lines of code as input for calculating those effort and time. But here in intermediate COCOMO model, we'll be getting accuracy by incorporating the 15 cost drivers. Those are depends upon reliability, experience, and capability. These drivers are rated to calculate the effort adjustment factor, which is nothing but EAF. And we'll be going to use this factor in our further calculations that's in intermediate COCOMO model. And for these are being used just to get accurate values that's for better effort and time estimations. Let us see this 15 cost drivers have been characterized in 4 different categories, and those are product attributes, hardware attributes, personal and project attributes. This effort estimation, effort adjustment factor is nothing but those are rated on the basis of their impact. Like how will be the impact of this particular cost driver? It bases on 1, 2, 3 ratings, like low, medium, and high. EAF effort adjustment factor is being the product of all these costs cost driver values, and this EAF will be using for calculating time and effort like we have done in basic one, right? Here, there we just used a kilo lines of code as our input, but here we'll be using this EAF factor also, which gives some accurate values of accurate cost values. Let us see that. Similarly, we have formulas in basic one. Here also we are having, and EAF is the factor which is added in calculating effort. And rest of thing is similar to that of a basic model. And the table values are also similar, only we have the two values changed, and those are A value in organic and A value in embedded. That's it. And similarly, we'll be using these particular constant values in our calculation. Let us see an example. I have took a semi-detached project, which is nothing but one of the type of software projects. And semi-detached one is the one which lies in between organic and embedded one. This is just like an intermediate one. And kilo lines of code is 30 with EAF. Effort adjustment factor is given as 1.2. And for calculating this effort, which is the formula A into kilo lines of code power D into EAF. This is nothing but 1.2. See, we have substituted those values from the table in this formula and got the value as 131.29% months. And similarly, this is development time, which is the formula here C into effort power D. Here, effort we have got as 131.29, which is directly substituted in the place of effort, and C, D values are took from the table. And that too, we have considered only this particular column for calculating this example. And development time we got as 15.48 months, which means it requires 15.48 months to complete that particular project. And also the effort required is 131.29% per month. Okay, this is all about intermediate model. Let's quickly move to detailed COCOMO model. Here it extends intermediate model by accessing the cost drivers impact on each phase of the software engineering process. It uses different effort multiplexers for each cost driver attribute. It divides the software into modules and estimates effort and time, then sum up, like it will be dividing the entire into small chunks and then totally integrating them and getting the final effort. Here, there are six different phases of COCOMO model like planning and requirements, system design, detailed design, module cost and test, then integrating and testing, and finally reach to constructive cost model. Here, the effort calculation formula is function of program size plus cost drivers for each particular phase. Like I have mentioned, right? Here, it divides into small modules and then estimates effort and finally integrates it into a final one. Okay. This is COCOMO 2 model. It's a hierarchical estimation model with three different stages. The first one is application composition model, early design, and post architecture. In application composition, it is very early stage where UI prototyping and tech assessments. In early design, it's after requirement stabilization. And the last stage is post architecture, which is during software construction. And here, sizing options can be done using object points, functional points, and lines of code. Object points can be calculated based on screens, reports, and components. Like components, we have some, we'll be using some reusable components. Like for suppose, we'll import some already built-in codes which will be used for reducing our time and even our cost in developing a particular product. Complexity is based on simple, medium, or difficult. This is an example and the process how to calculate those estimations. These are the steps. First one, classify objects by complexities, then assign weights. Like, is this simple, medium, or difficult? After that, we'll be going to calculating this object points and then new object points. In new object points, we'll be adding reusable components. Like how much percentage will be we will be going to add, will be going to take as reusable ones, and how much should be developed from scratch. These all are included in this COCOMO 2. That's why it gives some accurate values of cost, or it might be of time and anything. And effort calculation, effort is 21.6, which is new object points by 7. It totally gives some approx value like 3% months, which means 3% are required per month to complete this particular project. So that's all about that COCOMO model, and I have mentioned the values, how are we going to taking those values in our formulae. And I have mentioned that basic COCOMO model just gives some rough calculations, whereas intermediate, detailed, and COCOMO 2 gives takes function points, object points, and also those methods, those models will give some accurate values. Let us see what are the advantages we have by using this COCOMO model for estimating cost. First of all, it provides accurate estimation for effort, time, and cost. And it helps in better project planning and resource management, suitable for different types of software projects. It's flexible and adaptability to various development environments. Project planning is must and should before entering into a project designing. Like without any plan, it's just like a stupidity to start a project designing, or it might be project coding or anything. We all require a plan and some estimations, like how much time it will be going to complete our project, and what is the cost we are going to invest it we are going to invest on this, and what all the things, how much profit we are getting from this. So these all can be possible by using some techniques like COCOMO model for estimation. Like everything, as it has pros, and also it contains some cons, and these are the disadvantages by using this COCOMO model. It requires accurate data for better results, and it might not be suitable for modern agile development practices, and its calculation is a bit lengthy process and it's time consuming one. So from all this, I want to conclude that COCOMO model is a vital tool for estimating software factors, software project factors, and those are like a time, cost, and efforts, helping teams to estimate projected timelines. Like up to this time, what we are going to complete from our project. Like estimations add can be used for getting appropriate results. By understanding these types and applications, software engineering teams can make informed decisions and also improve project planning, delivery, and especially this is very essential for large scale projects. Like the projects are very on large scale. Without any estimations, it's nothing. Like I have mentioned, it's stupidity to just enter into that without having any proper plan. So that's it. And these are the references from which I have took that software engineering practitioners approach, software engineering by KK Agarwal and some others. So thank you. This all the explanation about COCOMO model. So thank you for your attention.